Now the first part was just about why L'Hopital's rule is working and some very basic examples. The second kind of thing with L'Hopital's rule is basically, I should title this, don't be afraid to use L'Hopital's rule more than once. For example, I'll try to give two samples here. If I want to take a limit as x goes to 0 of something like sine x minus x all over x squared, like that. Now remember, you have to show you're in the case of L'Hopital's rule. If I plug in 0, I get 0 minus 0, so the whole top is getting tiny. The whole bottom's getting tiny, so we can do L'Hopital's rule. So we put a little equals, we put a little L hop here. Now how does L'Hopital's rule work? It says once you know you're in the case, take the derivative of the top. So I'm just going to get cosine x minus 1 all over 2x, and then I'm supposed to try to take the limit again. Well, when you plug in 0, the cosine of 0 is 1. 1 minus 1 is 0, so the whole top, again, is going to 0. The whole bottom is going to 0 again. Now, I don't know that it got any better, but we can use L'Hopital's rule again, so we're going to try. There are cases where you can use L'Hopital's rule forever and never get the answer, so be careful. Anyways, I can use L'Hopital's rule again. I take the derivative of the top, I get minus sine x. I take the derivative of the bottom, I get 2. I try to take the limit again. I'm going to get 0 over 2, and that's a perfectly good number. That's just 0. So we can use L'Hopital's rule more than once. This is a case that actually shows up some in Calc 2. Meanwhile, I'm going to take one example and I'll let you generalize it. This is just another example, but it's a very important one. In the first video, we took the limit of x over e to the x. Now I'm going to do something silly, like say, let's take x to the 100th over to e to the x. Now, x to the 100th is much, much bigger than x. But which one's bigger? In a pre-calculus class, you'll say the bottom's exponential, the top is power. Exponential functions dominate power functions, so you should get 0, but they don't tell you why. L'Hopital's rule will give us that. Let's just talk about this for a minute or two. The top is certainly getting huge. The bottom is certainly getting huge. We can certainly use L'Hopital's rule. So we write L hop over here. We take the derivative of the top. We get 100 x to the 99th. On the bottom we have e to the x. And we're supposed to take the limit all over again. Like that. Well, the top is getting close to 0. The bottom's getting close to 0. Now the power on the top got a little bit smaller. That's great. But we can use L'Hopital's rule again. So I'm going to tell everybody, hey, we're using L'Hopital's rule again. And we're going to get 100 times 99 times x to the 98th. On the bottom, we just get e to the x again. Right? And we're supposed to try to take the limit all over again. Well, the top is going to infinity. The bottom's going to infinity. And we can do this. Now it's like, well, I'm not going to do this anymore, but you know, the thing about it is, if we did this 100 times, so I'm just going to write L hop, and down here I'll put 100 times. The bottom will still be e to the x. If I take 100 derivatives of the top, there's no more x's left. What I have is 100 times 99 times 98 times 97 times 96, all the way down to 1. When you took your algebra class, you learned that that's actually called 100 factorial, and we're supposed to take the limit all over again. Just like that, right? But the top is now a constant. It's a big constant, but the bottom gets bigger and bigger and bigger. The bottom is still getting huge. The top is a big number, but it's fixed. It's not it's not growing anymore. So the answer actually is 0. And what we see here is that e to the x dominates x to the 100th. Now you should try to answer the question, what if that was x to the 1000th? What would change? And why would you get 0 again? And you'll finally answer the question that they do in algebra, that exponential functions dominate power functions, and why.